Let us now look at the basic theorems used in Boolean algebra to simplify Boolean expressions. Simplifying Boolean expressions will lead to a Boolean expression with lesser number of terms. This further implies lesser gates to implement the expression. Therefore, you have lesser circuit area. So the circuit occupies lesser area. If a circuit occupies lesser area, and has lesser number of gates, then you have lesser power dissipation. And lesser number of gates leads to lesser propagation delay. Which means that the inputs can be processed much quicker to produce an output. So let's see what the basic theorems are. So the first theorem is with zeros and ones, which states x or 0 is x and x or 1 is 1. You have already seen this before. The dual is x and 0 is a 0, x and 1 is an x. Then we have the idempotent law. So it's basically x or x is an x and x is an x. Next comes the involution law. So it's x prime, the whole prime is x. So you can prove all these theorems or all these laws by just substituting the values for x as 0 or 1. Then you have the law of complementarity, which is basically x or x prime is a 1 and the dual is x and x prime is a 0. So as per commutative law, x or y is y or x and the dual is x and y is y and x. So you have seen most of this in basic mathematics. In Boolean algebra, you have similar things. Next, we have the associative law. As per associative law, x or y or z is equivalent to x or y or z. And this can also be equal to x or y or z. The dual is x and y and z equals x and y and z, and this is equivalent to x and y and z. Then we have the distributive law, which is basically x and y or z is equal to x and y or x and z. And the dual is x or y and z is equivalent to x or y and x or z. So if you multiply this out, you're going to get this. You can try that actually. So let's do the proof. So let's take the RHS x or y and x or z. So let's start multiplying it out. So x dot x and x, or x and z, or x and y, or y and z. So you know that x and x is an x, xz, or xy, or yz. Now this is nothing but x times 1 or z, or xy or yz. So looking at your previous theorem, 1 or z is nothing but a 1. This is again the same, x or yz. We have already looked at the De Morgan's theorem, which is basically x or y whole prime is equivalent to x prime and y prime, and the dual is xy the whole prime is equivalent to x prime or y prime. And finally, we have the consensus theorem. So as per consensus theorem, you have xy or x prime z or yz is equivalent to xy or x prime z, and the dual is x or y and x prime or z and y or z is equivalent to x or y and x prime or z. So the two terms here, they are known as the consensus terms. So we are not going to do much on consensus theorem in this course because it's kind of tricky, but so just remember that there is a theorem called consensus theorem which you might use later in your higher courses. So using these 8 theorems, let us try to simplify Boolean expressions.